So let's talk about some different probabilities and what they mean. The probability, remember, we're representing as P of X, so that's the probability of event X happening. And if we have P of X equals 0, a probability of 0 means that the event is never going to happen. It's impossible. So we would say the event X is impossible. P of X equals 1, that would be the probability of event X occurring is 1, and 1 is the highest probability that you can have. So what it means is that event X is always going to occur, that it is completely expected every time. The next one shows the probability of X is 0.5, which is the same thing as the probability of X is 1/2. We can show it as a decimal or as a reduced fraction. The two mean exactly the same thing. And if you have a probability of 0.5, it means that your event is going to happen half of the time. And I put is likely to happen because if you only do one experiment, it might or it might not, and you would say, well, but that was a 0 or a 1. That's true, but over time with a large number of experiments, you expect X to happen half of the time. The next one, P of X equals 0.25 or P of X equals 1/4. Again, you can write it as a decimal or a fraction in its reduced form, and the two are equivalent. So this one means that the probability of your event X happening is 0.25 or happens 1/4 of the time. So you can put event X is likely to happen 1/4 of the time. And I just put these little tick marks here, which ended up looking like little N's, but they're supposed to be, it's my computer interface, but it's supposed to be a tick mark like that. P of X equals 0.1667 or P of X equals 1/6. If I take 1 divided by 6, I do get 0.166 repeating, and I just picked a certain number of decimals, and 5 in this case, and rounded to the 5th decimal place. And since a 6 was following, this bumped up to a 7. This means that your event is likely to happen 1/6 of the time. And you could also state any of these as the event X has a 0.16667 probability of occurring. So this is a probability, so you write the word probability with it, not percent. So formally, classical probability, if all outcomes are equally likely, remember the die toss and the coin flip. Classical probability is calculated with this formula, the probability of the event, and you can put P of whatever the event is, equals the number of possible outcomes over the number of outcomes in the sample space. And we wrote that on the page before, but the probability of the event will always be a real number. That means it's going to be like 1, 2, 3, and it could have decimals or something like that, but it's not going to be pi or some other, it could be pi. So it's not going to be outside the set of real numbers, but it's between 0 and 1, and it could have a value of 0 and it could have a value of 1, just like we saw up here. And it could have anything in between, any decimal value or fraction value in between. And so that one's kind of important to remember, that it's between 0 and 1. Inclusive means both the endpoints are also part of the values that could be found for a probability. Here's some questions for you to try out. See if you can think through these and figure out what a fraction would be to represent the classical probability for this event, the classical probability for this event, and for this event. And then you can convert them into decimals simply by taking the numerator divided by the denominator and then writing out a decimal form. If it doesn't truncate on its own, you can put, say, 4 decimal places would be good.